Welcome to The Explainer. Today, we're going to tackle a challenge that pretty much every AI developer hits sooner or later. How do you take one amazing AI agent and scale it up into a whole team of them? We're going to explore that journey from one to many and figure out how to do it right.
You know, a lot of AI projects start out just like this. You build one single brilliant agent. It's designed to solve a very specific problem, and man, it does it well. It's your star player. And this lone worker, well, it's often the perfect place to start. It's fast, it's efficient, and because you're only dealing with one thing, it's pretty simple to manage and to debug when things go wrong. But here's the catch. What happens when your agent's own success becomes its biggest problem? You keep adding more tools, more responsibilities, and suddenly that single agent, it starts to buckle under the weight. So today, we're going to walk through that scaling journey from a single worker to a whole coordinated team, all based on the core principles of agentic system design. Okay, so let's really dig in here. First, we need to understand the breaking point. Where exactly does that single agent hit a wall? When does its greatest strength, its simplicity, suddenly turn into its biggest weakness? And this is where you see that classic trade-off, right? A single agent is simple, it's fast, it's cheap, absolutely perfect for very focused jobs. But a multi-agent system, that's built for complexity. It's specialized, it's robust, but yeah, it comes with more overhead. It's really the classic monolith versus microservices debate, just playing out in the world of AI. Just try to picture this. A supply chain agent trying to manage 16 different tools. Yeah, 16. That's inventory, shipping, supplier evals, warehouse stuff, all being juggled by one brain. You can see how the complexity would just explode. And this leads to what you could call digital analysis paralysis. When you give one agent way too many choices, its performance just tanks. It might get confused, it could pick the wrong tool, or it might just slow way down, which kind of defeats the whole purpose of having an efficient AI in the first place. So, you see the problem, the solution? It's not about trying to make that one agent a superhero. It's about building a team. Just like we've learned in modern software engineering, sometimes you just have to break up the monolith. And the core idea here, the secret sauce, is something called task decomposition. Instead of having one agent try to do everything, you chop up the big, messy problem into smaller, logical pieces. Then, you assign each of those pieces to a specialist agent that's an expert in just that one thing. And this right here is a perfect example of how our supply chain problem gets solved. Those 16 tools, they weren't just a random pile. You can group them logically into 3 distinct jobs. Now you have one agent that only worries about what's in the warehouse, another one just worries about getting stuff from A to B, and a third one handles all the suppliers and the paperwork. Each one becomes a true expert. Of course, any team of specialists needs a manager, right? In this kind of setup, that role is filled by what we call a supervisor agent, and its only job is to look at a new request and figure out which specialist to send it to. It doesn't do the work itself, it just delegates. It's the traffic cop. Okay, so we've got our team, we've got our specialists, but now the really important question is, how do they actually work together? It's not enough just to have them. You need a strategy for how they coordinate to get something done. And really, you can think of this just like choosing a management style for a human team. On one side, you've got manager coordination. That's our supervisor model. It's centralized, it's fast, but if that supervisor goes down, the whole system can fail. On the other side, you have a democratic approach, where agents vote or build consensus. It's way more robust, much more flexible, but it can also be a lot slower. Here's another really powerful pattern for collaboration, the actor-critic model. This is like having a built-in quality control loop. One agent, the actor, proposes something. Let's say it writes a marketing email. Then a second agent, the critic, reviews that email against a set of rules, like does it match our brand voice? Is the tone right? If it's not good enough, it gets sent back with notes for a rewrite. This back and forth process really improves the quality of whatever you're creating. All right, but now let's look even further ahead, because we're going beyond these more traditional team structures. We're going to look at 2 approaches that are really pushing the boundaries, inspired by things in nature and the absolute cutting edge of AI research. So first up, you have swarms, and these are just fascinating. Instead of a few smart, specialized agents, you have a huge number of very simple agents. Each one is just following a few basic rules, but when they all interact, this intelligent, complex group behavior just emerges. I mean, think about an ant colony. There's no CEO ant telling everyone what to do, but together they pull off these incredibly complex projects. It's a model that is unbelievably robust and scalable.
But what if we could take it a step further? What if we could get the AI to design these agent systems for us? There's this groundbreaking concept, sometimes called ADAS, Automated Design of Agentic Systems, that aims to do just that. The whole idea is to stop designing these agent systems by hands.
I mean, the core idea is basically AI that designs other AI. It's pretty meta. You have this high-level meta agent that's like an AI architect. It comes up with new blueprints for agent teams, tests them out in simulations to see how well they work, and then it learns from the successful designs. It's literally an evolutionary process for creating better and better AI systems.
Okay, last but definitely not least, none of this works if the agents can't talk to each other. I mean, you can build the most brilliant team of specialists in the world, but if they're all locked in soundproof rooms, they're useless. For a multi-agent system, communication is everything. So to fix this communication gap, there's this really promising idea called the agent-to-agent or A2A protocol. The goal here is to create a universal language for agents, a standard way for them to say, hey, here's what I can do, and for other agents to make structured requests. Think of it like a universal API, but for autonomous AIs to find and work with each other. And this table here does a great job of laying out the options for the tech that makes this happen. For systems that just need to pass messages back and forth, you might use something like Kafka. For systems that need to be super resilient and handle tons of tasks at once, an actor framework like Ray is a great choice. And for those really long, complex jobs that absolutely cannot be allowed to fail, a workflow engine like Temporal gives you the durability you need. All right, so let's bring it all home. What are the big takeaways here? Well, it's all about starting simple, but always having a plan for how you're going to scale. It's about breaking down your problems into specialized roles, picking the right management style for your agent team, and never, ever underestimating how critical a good communication system is for keeping it all running. And as these systems keep evolving from single, simple assistants into these complex, collaborating teams, it leaves us with this really interesting, kind of mind-bending final thought. We're not just building AI assistants anymore. We are now the architects of entire AI organizations. The question is no longer just what can an AI do, but how can we best get them to work together?